Good morning, class. In our last class, we have seen the shape of orbitals sp and d orbitals, sp and d orbitals. Then after that, we have seen a very important principle, that is Aufbau principle. And if you remember the Aufbau principle, how I explained over there in our last class, you'll find that how the electrons are filled in various orbitals in order of the increasing energies. So the orbitals in the increasing order of energies are 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, and it goes on. This order you need to remember, because now after this we are going to write down the electronic configuration of the elements where we require this order. That means which orbital will come after which orbitals. Say for example, after 1s it will come 2s, then it comes 2p, like that. You need to remember. Okay, so this is a very important order. Next, maximum accommodation of s, p, d and f electrons. That means in s orbital, what is the maximum number of electron we can accommodate? Okay, so in s orbital, the maximum accommodation of electron is 2 electrons. We can accommodate 2 electrons. In p orbital, 6 electrons. In d orbital, 10 electrons, and in f orbital is 14 electrons. This maximum accommodation of different orbitals we have seen in the quantum numbers as well, when you have written the spin quantum number. So from there we can just remember, or you can just remember that s 2 electrons, p 6, d 10 and f 14. Okay, this we also required while writing the electronic configuration. Now let us come to the main topic of today's electronic configuration of elements. How we can write. Say for example, first let us try with the atomic number 1, that is hydrogen. Okay, so 1 which is written down is a atomic number, and the number which is written above is a mass number. So over here we need to consider only atomic number. So atomic number from there is 1. So number of electron will also be 1, because atomic number is the number of proton present inside the nucleus of an atom of an element, and number of proton is always equal to the number of electrons, so it's 1. Now for this 1 electron we will write down the electronic configuration. So according to the order, the first order, it is the first orbital that comes is 1s, and since we have got 1 electron, we write it as 1s, that 1 electron to the power of s. Got it? Now if you have got 2 electron, it is written as 1s2. Okay, it is written as 1s2, 1s2. And if it is 3 electron, then you write 1s2. Then we'll go for the next orbital. Why? Because the s orbital can accommodate maximum of 2 electrons, not more than that. So if we have got 3 electrons, then we write it as 1s2, 2s1. Are getting it? Next, one more example I have solved over here with carbon, atomic number 6. Atomic number is 6 over here. I'll just want to make a correction. Okay, atomic number is 6, and number of electron will also be 6. Okay, so that was a mistake. So atomic number 6 and number of electron is also 6. Okay, just replace this 1 and 1 by 6, 6. Okay, now how to write down the electronic configuration of this 6 electron? So we write it as first orbital is 1s, so 1s2. The second orbital we have got 2s, so 2s2, and we'll go for the next orbital, that is 2p. After 2s it is 2p, so that will have 2 electrons. So altogether we'll have 2 2 2 6 electrons. Got it? Remember that we need to keep in mind the maximum number of electron that an orbital can accommodate. Say for example, over here is it can accommodate only 2, not more than that. So you can replace 3. Okay, and then once again this p orbital maximum accommodation is 6, so we can go up to 6 electron. Okay, got it? So in a similar way in a similar way, your assignment for today is assignment number 17. Write the electronic configuration of the following elements: A. Helium, lithium, beryllium, boron, nitrogen, oxygen, fluorine, and neon. So in similar way, write down the electronic configurations, okay, and send it in my mail.